Hello, everyone. This is your instructor Jason back to deliver a video for you that is a bonus assignment. But I really hope all of you not only complete this video, submit this assignment, but also start using this concept going forward, especially when developing your personal project. So what we're going to talk about today, what I'm going to show you is how to write unit tests within C++ in Visual Studio. Now, if you've been using Dev or some other IDE, you won't have this testing framework available to you. So this is a Visual Studio specific video. Now, this concept, though, applies to C# in Visual Studio and Microsoft, and it also applies to Java. So I work for a company called Cognizant, and basically what we do is we contract developers out to these Fortune 500 companies that in a staff aug scenario where we're providing them developers for just a contracted amount of time for the duration of some software project. So I've seen a lot of different companies in industry, and these are big players in industry and the banking verticals. Name a credit card company, and I've probably worked for them. Name a large bank, name in healthcare, name an insurance provider, and we have provided developers for them. So what I'm seeing across the industry is this push towards shifting left, and what that means is you are trying to ensure quality in the beginning. You're writing the unit tests and writing the regression tests and integration tests. You're writing those tests as you develop the software product. In industry, what we are dealing with now is we have these cross-functional teams where you have developers of all range of ability and all specialization, and they're working together on this product, working closely with the business subject matter expert, and trying to develop these software products in an agile environment where they run these 2-week sprints, and at the end of each, or at the beginning of each sprint, at the end of each sprint, you decide what software feature needs to be added, what's the most important. Typically, you have a whole set of backlog items that you're trying to add that the business wants, whatever that might happen to be. So what I'm trying to say here is developers are being impressed to start writing the unit tests as they're developing the software, instead of that being a completely different person. So historically in industry, you would have a whole team of people that were called quality assurance engineers, or they'd have some name, QA, quality assurance, and their whole job was to write tests against the software, but they weren't the ones actually developing the software. So there's a disconnect there. They have to learn the software product, right? And then they may be writing these unit tests or these regression or integration tests, or end-to-end tests that are giving false positives because they don't exactly know. It's a black box testing. They don't exactly know how the software was written. So they may have incorrectly made some incorrect assumptions about the way it was written. So anyway, this is the shift left mentality that I'm seeing in industry. We want developers who can write the tests, and not only write the tests as they develop it, but write the test before they develop it. This is called test-driven development. There's also a you can take that a step further and do behavior-driven development. And unfortunately, in C++, we don't have a BDD framework, but we're going to do test-driven development today. So that's what we're going for here. All right, so what we're going to do here is we're going to start with our Teenage Mutant Ninja Turtle project. Reason being is this is the only project that we have that has a class structure, right? We've got this Ninja Turtle class. Let me zoom in for you here. We've got our Ninja Turtle class, and it's got private and public members here. And then we've got this program or runner program, our int main, which is exercising the class. It is instantiating a turtle and working with that library, working with that Ninja Turtle class. All right. And so this is the finished product. So what you can do is open your finished product and start there. I'm just going to show you where we're at here in the project. If I enter the turtle's name, let's do Leonardo. This time, his color blue. Wacky weapon, the katana. Let's say he was 18. No. Okay, so there it's displaying the information about our turtle, right? Okay, so in my runner program, I don't have Donatello in there anymore. I removed him. So it doesn't have a preloaded turtle. It is just asking you to type the turtle in, and then it displays it. Okay? All right, so let's write unit tests for this. Let's test what's already there, just so I can show you how to write unit tests, how to set them up in your project. Then we're going to do TDD, test-driven development. We're going to develop a new feature in our Ninja Turtle class, writing the unit test first. Okay. All right, so let's just get started here. So in Visual Studio, the unit tests that you write, or they can be integration or regression or whatever the test is doing, whatever it's focusing on. And those of you unfamiliar with those words I've been spitting out, regression, end-to-end, integration test, those are just different tests that are testing a software product at a different phase in its development, and it's testing different things about it. So integration test is testing the integration of multiple software features. Maybe you've got one website that reaches out to another website, or take any if we're dealing with video games, think of a video game that has to reach out to the server to get information, right? That server is a whole nother software product, and integration of the two is what you would test to make sure that it reached out, got the right information, brought it back. Regression testing, that is testing. Those are unit tests that you typically put into automation, and you run them every time you make a new release. And what they're aimed at doing is making sure that your software product didn't regress. So your regression tests are the key tests that are ensuring that the major, and you as a team you have to decide what those are, the major features of the software product are not failing now that you added some new feature, added some new aspect to your software product. So anyway, different types of testing within Visual Studio. The way that you set up a testing project is you right click on your solution, and you're going to add new project. And under new project, what we're going to use is this native unit test project. Now that's showing up on my recent. For you, you'll have to find it. If you just type in unit, it should show up. And there's a lot of options here. So you've got this C#. Here's what we want: C++, native unit test project. Native unit test project, C++. Make sure it's the C++. Now, C# obviously has unit testing, and Java does as well if you're in a Java IDE, Visual Basic. There's also this Google test, and I encourage you to test that library out. If that's a unit testing library that Google wrote. for C++. We're going to use the Microsoft CPP unit test framework. Okay, so this is this framework that Microsoft wrote. Okay, select that. Next, and then what are we going to call it? You typically call it the name, whatever it is, the project that's under test, or if it's a class that's under test, that's what you'd say, and then follow it with the word test. So I'm going to call this TMNT underscore tests, like that. Okay. All right, so this is what we get out of the box when we create a brand new unit testing project. It's already including a couple of libraries for us. It has a namespace that it's including for us, which is the CPP unit testing framework. And then we have this namespace, which is the name that you gave the project. And then you have this test class, and then we have a public member that's test method. So this is how it's set up as a class. Reason being, that way, if you wanted to automate your tests, then this class could be instantiated, and all of the methods could be exercised in automation, so that if you kick off a Jenkins job or in a CI/CD pipeline, again, if those words aren't familiar to you, I encourage you to look them up. Jenkins is just an automation framework or software piece that automates builds and tests and deployments. And a CI/CD pipeline is continuous integration, continuous deployment. And that's how software is delivered now. You've got this pipeline set up to where all you do is check in a piece of code into your repository, whether it be, most of the time it's going to be either GitHub or it's going to be one of the major cloud providers. Azure, which is Microsoft's product, has a DevOps product in its own repository. Microsoft bought GitHub, and then AWS has their own products, and there's a lot of products out there. But so this is how the testing framework is set up. It's set up as a class. It looks like a class. I know it's a little bit different as far as the syntax is concerned, but it is a class that can be instantiated and run in automation. That's one of the goals of writing tests for your software, and writing it as you develop your software, so that these tests can be kicked off automatically when you set up a continuous integration to continuous deployment or continuous delivery pipeline. Those are called CI/CD pipelines for short. That's how software is being delivered now in industry. When a feature is completed, the developers will push the code up, push their branch up to their repository, and then the team will merge the feature with the master branch, and then typically that merge feature in GitHub or whatever repository software your team is using, it can be integrated with the CI/CD pipeline software like Jenkins or Concourse, and those software pieces will automatically kick off a build and run the unit tests and test them against run all the tests against the software, and if any tests fail, then it won't deploy the application to production. Okay, so this is our ARC test, and what we're going to do here is change the name of the method. And I know that it looks odd here. This is the actual name of the class, and this is the name of the method. These are just kind of wrappers for them in this unit testing framework. So don't get hung up on this stuff too much. Just focus on focus on writing the method, which is what we're going to do. This being the name of the method, I'm going to change it to reflect what the method should be testing. Okay, so I'm going to change this name to Ninja Turtle toString. I want to write a unit test that tests the toString method. I'm going to say prints correct message. Okay. And this is a convention in industry. Your method names in your unit test class are ridiculously long, but what they serve as is living documentation. So instead of writing a bunch of comments about what the test is doing, you put that directly into the method name. That makes it visible externally, and it becomes this living documentation. So what is this unit test testing? It's testing toString to make sure it prints the correct message. So how do we do that? Now, writing a unit test, there's a couple of different mnemonic devices to remember how to go about it. There's arrange, act, and assert is one way to go about it. There's another acronym, SET, S-E-T, and that one stands for Setup, Exercise, Test. Same sort of thing here. So when you're writing a unit test, you first have to set the groundwork. In order to test this Ninja Turtle class, I need an instance of the class, right? So I'm going to create an instance of Ninja Turtle. Let's call it MyTurtle. And I'm going to pass into it my Ninja Turtle aspects name, age, and this class, I forgot what order I did it. I did name, age, color, wacky weapon. Color purple, wacky weapon, bow. All right. Now here you can see it doesn't know Ninja Turtle. So that has to be imported, and my IntelliSense says add include, and there it's including that Ninja Turtle header file, getting it from the TMNT directory, backing out ... with that ... Okay, so now we have a Ninja Turtle. I've arranged. Also in the arrange portion, you have to set up or describe what you're expecting. What should be the end result? The toString method, what's the end result of that? So I'm going to create a string, call it expected message. And I'm going to set it equal to Donatello is 17, wears purple, and fights with the bow. Just like that. All right. That's what I'm expecting to come out of this method. So MyTurtle, call that message, toString. Okay, and I need to store it somewhere. I'm going to store it in a string calling it actual message. Arrange, act, and then our assertion. This is a concept that's new to unit testing. If you've never done unit testing, this is going to be new. There is an assert class that has methods that what they will do is they will display a message if what you're asserting fails, and let you know whether it failed or passed. And this is a whole class of methods. So notice if I type assert : this is a static class with methods that I can access directly. There's are equal, is null is true, are not equal. I want to assert that these are equal. I want to assert, that's the test. That's whether the test passes or fails. And notice here it says the expected comes first, followed by the actual. And you can also write your own custom message there if you want. But I am going to put expected in here. and then actual second. And that's it. Not too difficult, right, so far? So now that I have a test, how do you run the test? All right, so there should be a Test Explorer tab. And in the Test Explorer tab, you just click the run method, which, as you can see, it takes it a second to think about it. Now, this Test Explorer tab, that pane here, if you don't see it, if it's not open, just go up to Test at the top, and then there's an option, Test Explorer. You can also, the shortcut keys are Control-E-T. Test Explorer under the Test menu option. Okay, so I'm going to run this test, and that's run all that I just clicked. The single arrow is just run a single method that you select from the list, but we didn't have any in the list yet. So, all right, so see the green, everything passed. Now, you should never trust a test that you haven't seen fail. There's a mantra in this way of approaching development in the agile development called red, green, refactor. It's in test-driven development, in fact. Red, green, refactor. So you write the test, watch it fail. That's the red. Green is write the code to make the test pass, and then refactor if you need to, shorten your code, or if you feel like you could have done it better, then you've got a unit test that's already passing as a harness where you can make changes to your code body and be confident that all I have to do is click a button to see if my program is still working the way it should work. And that's really another for your level, you young developers, just in the class, in my class or in any class. That's going to be the biggest benefit to you, the developer. Think about the programs you've written for me up till now. How many times have you had to run your program and type stuff in and then see if it did what it was supposed to do? And you're just retyping the same stuff over and over. Unit tests automate that. So all you have to do is click one button, play, and it will type in all the stuff, do all the stuff for you, and check and see, and it will let you know if your application's running. So I want to see this test fail. So what I'm going to do is I'm going to just remove this comma and run it again. And you can run it from clicking this green check mark up here. Whatever, it may be a different. If the test failed, it may be an X. If it hasn't run yet, it's a diamond. You can run it from here. That runs just that test. Okay, rerunning it, watching it fail, and it failed. And so it said expected, and it shows you the expected. Actual, it shows what it got, missing the comma. Okay. All right. So so good. So let's put that comma back in. That's the Oxford comma, right? There we go. All right. So technically, the sentence isn't incorrect without that comma by newer standards, but the Oxford English Dictionary, or Oxford commas, as it's called, expects to have that comma following the last item in the list. All right. Okay, so that's writing unit tests. Not too difficult, right? And hopefully you can see the benefit of this. I'll show you an example of using this in a more complicated program with difficult algorithms, a difficult algorithm, and you can definitely see the benefit. But this is just getting you started, so we're using this easy Ninja Turtle class. All right, so now let's use tests to drive our development. So test-driven development. I'm going to create a new test method. And let's add a new feature to our Ninja Turtle class. Let's add an attack method. And let's say that we want this attack method to just print something to the screen saying that the Ninja Turtle attacked with their particular weapon. All right, so I'm going to say Ninja Turtle. I'm specifying the class it's coming from in the method name here, which is, it's fine. Maybe not necessary, but I'm going to say attack. Ninja Turtle attack. Prints, and we'll just say prints correct message, same thing. All right. So so here's our next unit test. Now this arrange is going to be pretty close to the same. I'm going to copy it. Those of you familiar with unit test writing, some of my developers may have already written unit test. You may see, well, if I've got duplicated stuff, I should migrate it out. And you can do that. You can write your you typically can write setup methods that happen before each unit test, but we're not going to spend time on that. So I'm just going to just copy and paste it for now. Now the method should, or the expected message should be different. I'm going to say Donatello attacked with his bow and sent that foot soldier packing. All right. In the act portion, our actual message is going to be equal to my turtle attack. So I'm exercising a method that doesn't even exist. This is test-driven development from its finest. We're going to have to create that method, right? And before we can even run this unit test. Now, some test environments allow you to create that declaration or a definition. In C#, you can right-click and it'll add that method to your class. So you can actually write code from the unit test. Unfortunately, here in C++, it doesn't do that. It thinks you want to add it to this method. C++ it's not as mature of a language as C# or Java. Okay, so that attack method, I want to go ahead and add that here. Let me reopen that. All right, so there's my toString, and let's have another method, string attack. And it's going to return a message. Let's just have it return empty string for now. So that's just a method stub, as it's sometimes called. Okay, so now that's showing up. It's happy. And now let's assert. I want to assert R equal expected and actual. There it is. All right, so now we have this test method. Now in C++, you have to save the class. And then even then the method doesn't show up. You might have to run all for it to, you know, basically scrub this class and find the or scan, not scrub, scan the class and find this new method. So it found this new method and it says failed. The expected was this, the actual nothing. All right, so we've seen this test fail. Now we want to make it pass. I want this attack method. I want to write the implementation of the method so that this test passes. Donatello attacked with, I said is, that should be his bow, and sent that foot soldier packing. All right, let's give that a shot here. So return. Okay, I'm going to do this name. Concatenate attacked with his weapon, this wacky weapon. Excuse me. And sent, did I say that foot soldier? Yeah, that. Okay. let's run our unit test now. And you can just run that individual test now, clicking on that test, clicking the arrow, the single green arrow key. Hey, now it passes. Awesome. So this is unit testing. This is test-driven development, writing the test and having it drive your code development. Okay, so you can use this to, it causes you to basically document how you expect your application to work before you write your application. And you're documenting it in a test. That's something usable versus documenting it in a piece of paper. In the old days, in what was called the waterfall software development method, there would be all this requirements gathering, and there'd be these huge long documents where that they would write out on type out what the requirement should be in English, and then write the software accordingly, and that has proven to fail. It takes too long for it takes too long to gather all of that information, for one, and in the time that you gathered all of those requirements, the industry may have changed. The industry is moving a lot faster these days, and the business subject matter experts may have decide, that it needs to be different. It needs to look different. It's because the competitor just came out with something new, right? So by writing these tests, we can document how our application should work and then write it immediately. All right, so let's take a look at a more complicated example. So here we have our Caesar Cipher project. Now, in order to write a unit test for a application, you need to have a class structure. That way you can call that class and call that method or that function as a class member. So what I've done is I've restructured the Caesar Cipher program to have a Cipher header file with a class called Cipher, and the public in the public section of the class, the Cipher class, I have a string encode method. It returns a string, and there you can see that's just the encode method. I've made it a class function. Okay, there it is. And then I also have the decode method, and what I'm having this decode method do is I'm having it return a vector of string objects. And so we have a nested for loops looping through the numbers 1 through 25 on the outer loop. The inner loop is looping through every letter in that particular or looping through every letter in the coded message, and then transposing it by that outer shift number. Okay, so it's just producing a possibility, and I'm pushing that back to this decoded messages vector. That's what I'm returning. Okay, and so in order to write a unit test for this, and really with TDD, this is what makes development a lot easier. Think about how many times in just this class or any other programming class you've taken where there's some function you're trying to get to work, and you just keep rerunning your program, and you have to manually type in all of the responses and whatnot and interact. And so you're manually running the program every single time. And it may crash, and then you can't see why it did unless you put a debug stop point in there. So with TDD and writing a unit test for a really complicated method first, you can just rerun that unit test to see if it passes, and it will tell you why it didn't, and then you can try to fix the reasons it didn't. So let's take a look at the unit test that I wrote for this class, and I've just already got it done for you here to save time. Here you can see I've created a Caesar tests project, and here is the Caesar test file. Here's the single method that I've created. that is testing the decode function. I have decode returns possibilities with one correct. So think about that. The decode the decode function should be spitting out 25 different possibilities. Only one of them is the right one. So how do we write a unit test that makes sure one of them is the possibility? Well, I've already got it set up to where that will work. I have a decode function that returns a vector of possibilities, right? Okay, so my test method is going to shake out like this. I start with an encoded string, and I created that from the running program and just kind of jotted it down. Hard coding here my encoded message. This is what the message is. And I have a Boolean match found false. And here's the vector. Here we're acting, exercising the code, passing that encoded message in there. And then we are asserting. So in a for loop, I am looking at every one of the possibilities inside the vector. And that particular possibility, one of them should be attack at dawn. And so if I find one of them that is equal to attack at dawn, then I am setting that Boolean flag to true. And then lastly here, assert is true match found. All right. So if I run this unit test, you'll see it pass. And building this unit test, then you could start writing the method, decode method, until that passes. Okay, so here's the test explorer. Here you can see that unit test passed. So a little bit more complicated example. So again, to write unit tests, you may have to restructure the program. You may have to create a class structure if it's more convenient to test that way. But this is unit testing, and trust me, this is the way the industry is going right now. If you applied to my company in the digital business area, that development team they're a horizontal actually that cuts through all of the verticals in the company, but they are looking for developers who can use TDD to write a program. We're a Java shop for the most part, so they're looking for people who can sit down on a project and write a Java application using TDD and using mocks and stubs, maybe even using Cucumber, the behavioral driven development framework. That's very important in industry as well, converting the requirements, converting them into regular English language. I encourage you to look up BDD and look up Gherkin and Cucumber. In .NET, if any of you are .NET developers at OTC, C# developers, look at SpecFlow and practice with SpecFlow. But this is a very, very key skill. And I hope you enjoyed this video, and for 20 extra credit points, add either this unit test, the Caesar Cipher unit test, or the Ninja Turtle unit test, and send that to me by Sunday night, and I will give you those 20 points. Okay? Thanks a lot, everybody. It's been a hectic semester for me, maybe for you too. Enjoyed it. Don't hesitate to email me if you have any questions. Oh, and as always, know thyself.